coordinate diagram below shows the line segment AC and the points B, 4, 1 and P, 3, 3. So for part A, we have to write down the coordinates of the point A and the point C. So with these ones, always X first and then Y. So -1, 1, and then for point C, it will be 5 and 4. So we always go down, that will be our first point, and then across, that will be our second point. Down 5, across 4. For B, part 1, we are told that D is a point that's not shown. D is the image of the point B under central symmetry in the point P. What that means is that we have to think what would happen if it was sort of a mirror shape. So if we go from B to P, we have to extend that past. So can't draw a straight line here, but just imagine you extend that straight past P, it will end up here. So actually, let's draw that using this tool here. So that would be up to here. And then we have point D here. So that's under central symmetry. So what you do is you draw a line from B to P and through, and then you use a compass to mark off. You put your point P, you go to B, and then the same here. Or you could just use the grids to get the point. So then we want to draw the quadrilateral ABCD. So we'll just join all of these points here. So we have a four-sided shape. Okay, then for 2, Kate says the quadrilateral ABCD is not a parallelogram. Find the length of AB and CD and use these values to explain why K is correct. So first of all, let's talk about the theory. So we know that in a parallelogram, the opposite sides will always have to be equal. So if we find AB and CD and they won't be equal, that means that it will not be a parallel. So let's just do it on the right here. So the length AB. AB will be the easier of the two because it's a straight line. So the height doesn't change at all. So it's literally just this distance here. So from -1 to 4. So that will be a distance of 5. Now, to find the distance from C to D, we can either use the distance formula or Pythagoras theorem. So whichever you prefer. I myself prefer to use a Pythagoras theorem, so we'll do it like this. By the way, the distance formula is Pythagoras theorem, but we can sort of do it ourselves like this. So from D to C, we're going down 1. So this side of our triangle will be 1. And we're going across 3. So this will be 3. Now, once we find the hypotenuse, that will just be our distance between them. So all we have to do is 3 squared. So let's just call this side A. 3 squared, or to keep this sort of the same as the form, let's call it C. So 3 squared plus 1 squared will be equal to C squared. Let's square root both sides. 3 squared plus 1 squared is equal to C. So the square root of 3 squared is going to be 9 plus 1 is going to be 10. The square root of 10 is equal to C. So the length of CD is equal to the square root of 10. If we want to write that as a number, so we want to do square root of 10, that will be 3.16. So we want to explain why K is not correct. So we could say 3.16 is not equal to 5. So the length CD is not equal to the length AB. So this sign here just means not equal. And that is our answer to B, part 2.